Good morning, everyone. This is Sachin Fiske from Electrical Engineering Department, SND College of Engineering and Research Center. In the previous lecture, we discussed about the stability, root locus, and root locus for second order system. Now we are moving towards the properties of root locus. What is exactly the properties of root locus? We discussed here. So here some properties of the root locus are mentioned. Let us see one by one. So first property of the root locus is that the root locus has as many branches as the number of the poles of the open loop transfer function K1 into G1 of S. Each branch starts at a pole of function G1 of S and ends in a zero of function G1 of S or at the infinity. Second property, the root locus is symmetrical with respect to the real axis. Third property, if the constant K1 is positive, a point of a real axis belongs to the root locus if an odd number of the poles and zeros is left to its right. If constant K1 is negative, a point of the real axis belongs to the root locus if an even number of poles and zeros is left to the right. Property number 4, let K1 be the positive constant for K1 is equals to 0. The root locus leaves the pole Pi with the following angle. So 2V plus 1 into pi plus summation of j equals to 1 to m arg pi minus zj minus summation of j belongs to j dash an argument of pi minus pj. Here j omega dash is equals to 1 2 then j minus 1 then I minus 1 and n varies slowly. For the value k1 is to infinity, the root locus tends to 0, that is zi with some angle, and that angle equals to 2v plus 1, which tends to pi, and some argumented value, that is j tends to jn and zi minus zj, where j double dash is equals to 1 2 3 and so on, where I minus 1 plus I plus 1 and up to value of n. And if the constant k1 is positive in the previous statement, the term 2v plus 1 into pi must be replaced by the term 2v pi. It is shown in the following figure. The property number 5, a root of the order h corresponding to a point sh which belongs to h branches of the root locus. The point s of h satisfies the characteristic equation 1 plus k1 g1 of s is equals to 0 and its derivative with respect to the value of s, that is s domain system, and up to the order of h minus 1. This h minus 1 indicates the derivative of s of g1 of s is equals to 0, and it is the derivative of h minus 1 of g1 of s that is equals to again 0. Here there are some cases, that is h is equals to 2 for increasing the value of the parameter k1. Two branches of the root locus enters the point S2 in the opposite directions and then exits S2 along directions which are perpendicular to the entering direction. See there, these two diagrams are given. So what is the value of this pi by 2 and pi by 3? How it can be indicated in a particular locus diagram or root locus or a graph locus? It can be shown underlined. There are two more properties, that is, in the neighborhood of the root s of h is the order of h in a root locus. There are h branches entering at the point sh and h number of the branches existing at the same point. And this entering and existing branches are alternate each other, and locally they divide the plane into equal sector of pi by h radians. And last property is the number of the asymptotes of the root locus is equals to the relative degree, that is r equals to n minus m we discussed earlier, and the asymptotes that are half line which divides the plane in equal sector and which exists from the following point of the real axis. So which are the real axis? Yes, definitely it is the sigma A is equals to, in numerator you have to write, take it as the 1, and in denominator we have to consider the value of a relative degree, and this value of the relative degree will be considered as n minus m. If we consider the constant k1 as a positive, the asymptote forms the following angle with the real axis, that is omega AV is equals to 2v plus 1 into pi upon n minus m, where v is equals to 0 to m minus n minus 1. And if the constant k1 is negative, then the asymptotes from the following angle with the real axis as 2v pi upon n minus m, and the values can be lies in between 0, 1, 2 up to n minus m minus 1. Thank you.